I want to show you how to do transition metal formulas. With regards to them, there's really not much different. Besides, you have a couple of options here per element. So when you're looking at transition metals, oftentimes transition metals will have more than one oxidation state or more than one charge. Iron's a good example of that. And so we're going to go ahead and look at that one and do a couple of examples. So if you would look at your ion list, you will find that iron has two varieties there. It has iron 2, there's a Roman numeral 2, and iron 3. Okay. Now, what that means is you actually have two oxidation states there. So to write the correct charge form, iron 2 would have the +2 charge, iron 3 would have a +3 charge. Now, this will affect the formula and overall the molecule itself, so you actually have to consider which one you're dealing with in each case. So we're going to use these charges down below in an example here. Okay, so let's look at an example. Okay, let's say we have two different forms of iron. Okay, and they're both oxides. So we'll have iron 2, okay, oxide, which is just a combination of oxygen, okay, and then we're going to have iron 3 oxide. Okay. So if you're dealing with iron 2 oxide, as you guys saw above, you're dealing with iron of the +2 variety. Oxide is oxygen, and oxygen has a -2, okay? Oxidation state or charge. Now, if you would go ahead and do the crossover method with these guys, okay, you get Fe2O2. Now, if you go back and look at the notes, okay, 2 2's will simplify out because you can reduce those down, and what you end up getting is Feo, which is, Spanish for ugly, but it's also iron 2 oxide. So that is, okay, the formula for iron 2 oxide. Now, if I look, oops, not what I wanted to do there. If I look at iron 3 oxide, okay, to set that up, okay, instead of using Fe+2, it's Fe+3. Oxide is still oxygen with a -2. Okay. Now we're doing the crossover method to formula writing, so you're going to use this 3 and this 2, okay, gives the other one. And so when we rewrite this, okay, with the formula, you get Fe2O3. Now 2 and 3 won't simplify down, so that's as far as it goes. Okay, Fe2O3. Now notice the differences here. Okay, same iron oxygen, okay, being present in a molecule. Okay, oxygen and iron present in the molecule, but here you only have one iron atom and one oxygen atom. Here you have 2 iron atoms and 3 oxygen atoms. Okay, so there's definitely a difference, not just in name, but formula as well.